Okay, so I'm going to make a video here on the 3.4, questions 3 and 4, because I think that'll make more sense. Okay, so what they want us to find is the derivative of the inverse function at b. So I'm just thinking, all right, that's 1 over the derivative of the regular function at a. So here they're giving me the regular function, and they're giving me point b. So I got to find point a. Now, the reason that they've given us this right here is because we're going to be talking about inverse sine. And when you're dealing with inverse sine on trigonometry, you got to remember was a very tricky part from trig. Inverse sine can only be in these two quadrants. Okay, so you're only looking in here, between here and here. Okay. Okay, so I'm going to say I got to figure out what a is. So I know that this is the y value right here. So I'm going to put that in, that 1/2 is the sine of x. So I'm thinking the sine of what is equal to 1/2? And it has to be in these two quadrants. Well, I know the sign is positive, so it's got to be in this quadrant right here. And the one that works is pi over 6. Okay, so x has to be. Now, if you're wondering, okay, what does that have to do with an inverse sine? If I wanted to solve this for x, what I would do is I would say sine -1 of 1/2. And again, normally we don't show this. We don't show that we're taking the inverse sine of both sides. We just kind of write it. So that cancels out. And I could say that x is the inverse sine of 1/2. But I really prefer to think about it this way up here, is what angle has a sine that's equal to 1/2? And it's going to be pi over 6. Okay, so now I want to find 1 over f prime of pi over 6. Okay, so let's see, f prime, the derivative of sine of x is cosine x. So we want to find 1 over cosine of pi over 6. And the cosine of pi over 6 is going to be square root of 3 over 2. So let's see, so 1 over square root of 3 over 2 would be 2 over the square root of 3, which is 2 radical 3 over 3. Okay. All right, let's look at number 4. So on this one, we have a double angle in here. Cosine of 2x, b equals 1. And again, we're going to be working on an inverse function, and they're telling us to limit it to this quadrant right here. So we're being limited to quadrant 1 in here. Okay, so sometimes when I'm dealing with a double function like that, or what do I want to say, a double angle, I'm going to put a u in. And I'm not sure how you guys did this with Mr. Russell, but if I say I'm going to let u equal 2x, and then I could say, well, the cosine of u is equal to 1. Okay, so what I'm trying to do is I'm trying to figure out the a value that goes with this. And the double angle is kind of hard right there. So the cosine of u is 1. Okay, the cosine of what is 1? Well, that should be 0. So in this case, it's not going to make much difference, but let's say it was like pi over 6, it would make a huge difference. So now I got to figure out, okay, well, if 2x equals 0, then x has to be 0. Okay, so now I'm going to find 1 over f prime at 0. Okay, derivative of cosine of 2x, 2 sine 2x. Oops, and I guess I should have a 1 over that. Okay, that looks kind of funky. But, so let's go, then it's going to be 1 over 2 times the sine of 2 times 0. 2 sine of 0. Well, the sine of 0 is 0. So that comes out to 1 over 0, which is undefined. Okay, but I do want you to watch out for a double angle here, because if this was anything other than 0, that would come into play. Alrighty.